Okay, so basically, starting off, we're going to define standing waves, nodes, and antinodes. Standing waves, which can also be called room modes, they occur when sound is reflected off of, a parallel surface, walls. When the sound reflects off of walls and it travels right back in its own path and it interacts with itself, changing it. Um, it'll increase and decrease volumes around the room. It'll cause what we call nodes and antinodes. Point of a node is a point of no motion. It's where the wave interacts with itself. A crest meets a trough in the wave, and it causes sound to be either very, very quiet or non-existent. It causes silence. Now, the opposite of that is an antinode. This is what's called a point of maximum amplification. It's where the waves will interact with each other, and you'll have pockets within the room where sound is incredibly loud, and it'll only be loud in those areas. Now, you don't want these in a recording studio because it's going to mess with what you hear. It can cause problems in your mix. Standing waves will cause reverberation throughout the room. It'll cause vibrations, which will give unneeded sound. Some ways that you can fix this is to turn the volume down. Try and work in a room that's not completely square so that you have fewer parallel surfaces for these waves to bounce off of. You can use foam and things like that to try and absorb some of the sound so that it's not bouncing back. Or you can use deflectors so that it's not coming off. When the sound hits the wall, it's not coming off at an exact return so that it doesn't give you those reverberations. Now, in here, we need to measure the wall behind me. We need to measure the wall over here. We need to measure from top to ceiling. So, okay, and that wall comes to 15 feet and 10 inches, which, converting that to a decimal, is 15.83 repeating. And now we will. And this long wall comes to 23 feet and 6 inches, so 23 and a half feet. And then we measure from floor to ceiling is 7 feet 3 inches, so that comes to 7.25 feet. Now, the formula that we would use to find in what room that these standing waves would fit would be what we call velocity over the frequency, which would equal what we call lambda in feet. But we already know the measurements of the wall. We're trying to figure out what the standing frequencies, what the standing waves would be in here, what the frequencies of those waves would be. So we would modify it to, it would be frequency equals velocity, which is 1,130 over lambda, over your measurements. So using the calculator on the phone, we take 1,130. If we divide that by the 23.5 feet, we get 48.0510, very long number. If we round that off to 3 sig figs, because of the measurement that we got for the wall, it comes out to 48.1 feet. Now, we do the same thing for the short wall. So we take 1130, we divide it by 15.83, just rounding that off to 3, so it'll be 4 sig figs, and we get 71.383, big long number. And rounding that off to 4 sig figs, we get 71. We get 71.38 as our frequency. Then we do it one more time from floor to ceiling. So we take 1130 and we divide it by 7.25, and we get 155.862. And we round that off to 3 sig figs because of the conversion of the decimal in the measurements. And that rounds off to 156 feet exactly. So there are your standing frequencies for this room.